Good morning. I'm Faiz Zainesi
And I'm Brian Alvin.
of Class 11 Bharatiya Vidya. Today we are going to talk about ionic cluster and the board we made by using the principle of ionic cluster. First of all, what is an ionic cluster? Ionic cluster is a form of electric propulsion used for spacecraft propulsion. An ion cluster creates a cloud of positive ions from a neutral gas by ionizing it to extract some electrons from its atoms. Its principle is quite simple. Ion cluster work by accelerating ions, typically xenon gas, to generate thrust. They use electrical energy to ionize and accelerate the propellant, expelling it at high speed to produce the reaction force. Its key components are ionization chamber, accelerator, power source, and control system.
Some of the main types of ionic clusters are electrostatic ionic cluster, electromagnetic ionic cluster, Hall effect cluster. Some of the key advantages are high specific impulse, low fuel consumption, high thrust to power ratio. Applications of ionic cluster are space exploration, satellite station keeping, interstellar travel. Some of the current research into ionic clusters are advanced ionic cluster design, alternate propellants, nuclear power sources. Take a look at some of the components. These are two AA batteries in a battery holder that are producing a total voltage of 3 volts, which is connected to a step-up module which converts this 3 volts into 400 kilovolts, which is connected via these two alligator clips into this coil of 17 gauge copper wire and this piece of aluminum sheet. Let's take a look at how it works.
Imagine a spacecraft gliding silently through the cosmos, its engine glowing softly with blue light. This is not science fiction. It's the magic of an ionic thruster.
Ionic thruster? What is it exactly?
At its core, an ionic thruster, or ion propulsion system, is a type of electric propulsion used in spacecraft. Unlike conventional rockets that burn fuel and expel it rapidly to generate thrust, ionic thrusters use electricity to accelerate ions to create thrust.
How does it work, by the way?
Here's how it works. First, the thruster ionizes a gas, typically xenon. This means it strips electrons from the gas atoms, creating positively charged ions. Then, these ions are accelerated by electric fields and expelled out the back of the thruster. This process generates thrust in the opposite direction, propelling the spacecraft forward. Ionic thrusters are incredibly efficient compared to traditional chemical rockets. They provide much higher specific impulse, meaning they use less propellant to produce the same amount of thrust over time. This efficiency is crucial for long-duration space missions. Practically, ionic thrusters have been used in various missions. NASA's Deep Space One, launched in 1998, was one of the first to use this technology to explore the asteroid belt and the comet Borrelly. More recently, the European Space Agency's Smart One used an ionic thruster to study the Moon, demonstrating its capability for deep space exploration.
How do ionic thrusters achieve greater efficiency and longevity compared to traditional rockets?
The innovation of ionic thrusters lies in their efficiency and longevity. Unlike traditional rockets that carry large amounts of propellant, ionic thrusters use their fuel more economically, allowing spacecraft to travel further and operate for longer periods. This makes them ideal for missions to distant planets, moons, and beyond.